Welcome to 5.3, the other trigonometric functions. So these ones we're going to go through. As you can see, there are 4 other ones other than sine and cosine. These are all made up of sine and cosine, as you will see. We'll go over them very quickly. So tangent, secant, cosecant, and cotangent. So notice that tangent is y over x. So tangent is equivalent to sine of t over cosine of t. Because remember, y is sine and x is cosine. So cosecant is 1 over y, which is equal to 1 over sine of t. Secant is 1 over x, which is 1 over cosine of t. And notice that tangent and cotangent are reciprocals of each other. So cotangent is actually 1 over tangent, which is actually cosine over sine. And that's very important. So now we have all 6 trigonometric functions. There will be others, but as of now, we're just going to focus on these 6. So what we can do is, using x and y, that's sine and cosine, we can actually make these. Let me see if I can get in. There we go. So our y was half, our x was negative root 3 over 2. Notice that for tangent, we just put y over x and we simplified. You will have to rationalize denominators. So if you're not familiar with that process from Algebra 2, go back and maybe review it. Notice that secant is 1 over x, which is 1 over cosine. Again, it had to be rationalized. Notice cosecant is 1 over sine. And remember, when you divide by a fraction, it's just that fraction flipped, if it's 1 on top. If it were some other number, so it's some number here, and you're dividing by a fraction, then it would be that number multiplied by the flipped fraction. So notice cotangent is the reciprocal of tangent. So that means that if I flipped tangent, I would get negative 3 over root 3. And after I rationalize, I am going to get, that's going to be 3 root 3. And then root 3 times root 3 is 3. So we're going to cancel. It's going to be negative. And you get negative root 3. So it is just the reciprocal of the tangent. So here, this is x and this is y. A lot of trig work is going to be best done not if I do the example for you, but if you do it for yourself. Trig requires an extensive amount of practice. So I would recommend looking at the end of chapter questions and just understanding how you make these things. Okay, that's another example. Now this is what I would like for you guys to see. So these are the major angles in the first quadrant, quadrant 1, which is this quadrant, which goes from 0 to 90 degrees, or it goes from 0 radians to pi over 2 radians. This is a table. Notice that we have some cosecant and cotangents that are undefined, and that is because, for example, the cosecant is 1 over sine. So since the bottom can't be 0, it's going to be undefined where sine equals 0. Tangent will be undefined where cosine equals 0. Secant will also be undefined where cosine equals 0. Okay. We're not going to worry so much about reference angles. Okay, even and odd functions. So these are identities that you will need to know. So what this means is that if I want sine of negative pi over 4, now the thing about sine and cosines are you generally do not have anything negative on the inside. So that's why these identities exist. So that would tell me that that's equal to negative sine pi over 4. And this would be the proper way to write it, not this with a negative on the inside. So that is kind of why these exist. So you can get the angle directly from the unit circle without having to go negative, because it's just not, traditionally we don't use those negative angles on the inside. So these should be memorized, written down on a cheat sheet, preferably memorize them, but I understand some students will not be seeing this again. All right, now we're going to go over some more. So some fundamental identities. These are the ones that I talked about earlier. These are reciprocal identities, these ones that are in fraction form. So what this says is that the secant of pi over 4, for example, is the same as 1 over the cosine of pi over 4. So if you don't know what the secant of pi over 4 is, you can evaluate it by getting the reciprocal of the cosine, and that would be your answer. These are also important. I would recommend writing them down on a cheat sheet or something. Notice here that when we simplify expressions, it's a good idea to get everything in terms of sine and cosine so that everything can be crossed out. So notice these cosines cancel. That's okay. So that you get 1 over sine, which is actually cosecant. So anytime your book says we've established a new identity, don't worry about that. I'll let you know which identities you need to remember. Okay, so these are alternate forms of the Pythagorean identity. So the Pythagorean identity is cosine squared t plus sine squared t equals 1. And you can get these out of that. So these will also have to be remembered. The period of a function. So the period of a repeating function is the number that represents an interval, so that if I were to add it, you would get right back to the normal function. So notice the period of a tangent and cotangent is pi. So that means if I add pi, I can get right back to where I started. Notice the circular ones, cosine, secant, sine, and cosecant, it's 2 pi, so that's a whole circle. So that means after an entire circle, you'll get back to where you started in terms of those. So they'll repeat every full circle. The tangent and cotangent will repeat every half circle. And that is what is important here, that you understand these repeat in a full circle and these repeat in a half circle. Okay. Evaluating them with a calculator. These should also be somewhere on your calculator. Notice that if you use any of the reciprocal functions, you'll have to put 1 over the traditional function. So if you want cosecant, you have to do 1 divided by whatever your sine is. Be sure to make sure that if you're using degrees on the inside, it's in degree mode. If you're using radians on the inside, it is in radian mode. You'll get the wrong answer if it's not. Okay, that pretty much sums it up for 5.3. Again, this whole chapter 5 is like relatively short. 6 is going to be just slightly shorter. So thank you for watching, and I will see you in the next one.